It started with a strange silence, a sudden drop in the signal we've been tracking for decades, gone, as if swallowed by the void. Orbiting silently above us, hidden among the debris of time, is a spacecraft older than most nations on Earth. But now, something's different. Its path has shifted. Its decay is accelerating. And if our data is correct, this ancient object might be on a slow, silent descent back toward our planet. What secrets does it still carry? Who built it? And why has it remained undisturbed for so long? The sky holds its breath, and we do too, because what falls from space is never just metal and wires. It's history, mystery, and possibly even danger. In this video, we'll explore the origins of this spacecraft and the mind-blowing technology it may still carry, uncover the cosmic forces that could be dragging it back to Earth, examine the risks of a reentry no one is prepared for, and ask a haunting question. What if it wasn't built by us? Launched in the early days of deep space exploration, this spacecraft, known in official records as Sentinel 9, was once a beacon of human ambition. Positioned in a high, elliptical orbit well beyond the typical range of modern satellites, it was designed to study cosmic radiation and solar winds at a time when our knowledge of space was still in its infancy. For decades it remained out there, drifting silently, transmitting fragments of data back to Earth. Most people forgot it even existed, but astronomers never truly stopped watching. Located roughly 36,000 kilometers above Earth's surface, it has always been just on the edge of our awareness, a relic floating in the cold dark like a tombstone from another era. Then, a few weeks ago, something changed. High-powered telescopes recorded a subtle but undeniable shift in its orbital path, a wobble, barely noticeable but persistent. Soon after, faint electromagnetic pulses began radiating from its general location. These emissions don't match the original signal patterns recorded decades ago. They're irregular, almost rhythmic, like a whisper trying to reach across the vastness. Scientists were stunned. Was it a mechanical failure after all this time, or something else entirely? What makes this even more mysterious is that Sentinel 9 was thought to be completely inoperative since the late 1990s. Yet here it is, alive in some form and seemingly drifting downward. This marks the first time in history that an object this old and this distant has begun an unplanned descent back toward Earth, raising questions we may not be ready to answer. To understand what might be happening with Sentinel 9, we have to dive into some orbital mechanics and the quiet forces at play in space. Objects in orbit around Earth don't just float forever. Over time, even the smallest forces, like atmospheric drag at high altitudes or the gentle push of solar radiation, can destabilize an object's path. Sentinel 9, despite its distant orbit, has been slowly losing energy. And recent data suggests it's entered what scientists call orbital decay. Imagine a spinning top losing speed. It starts to wobble, spiral inward, and eventually falls. That's what we're seeing now. The spacecraft's motion has become erratic, suggesting it's slipping into a lower orbit, and gravity is beginning to take over. But that alone doesn't explain everything. The mysterious electromagnetic pulses being picked up by radio observatories across the globe have scientists especially intrigued. They resemble bursts we sometimes detect from decaying satellites, but they're too regular, too structured. It's like hearing a melody in static. Some experts believe residual energy within the spacecraft's ancient onboard systems could be intermittently activating. Others suggest external influences, like exposure to heightened solar activity, might be triggering old components. Tools like the Hubble Space Telescope and Earth-based radio arrays have been watching closely. Ground stations equipped with deep space antennas have locked in on Sentinel 9's trajectory, while scientists at facilities like the Very Large Array in New Mexico are analyzing the signal emissions in real time. Even gravitational observatories have been alerted, just in case there's an unforeseen interaction with nearby cosmic bodies or space debris. The real tension lies in what we don't yet understand. Could this be a simple case of long-delayed decay, or is there something else triggering this sudden return? Sentinel-9's behavior doesn't quite match the models we've built around space junk. And if the data is correct, we may have only a matter of weeks, maybe days, before it re-enters Earth's upper atmosphere. For now, the only certainty is uncertainty. Something forgotten is waking up, and it's coming back home. Based on current projections, Sentinel-9's descent could reach a critical phase within just a few weeks. Its orbit is decaying faster than expected, and tracking models show a slow spiral that's drawing it closer to Earth's upper atmosphere with each pass. If the current pace continues, we might witness reentry in less than a month. But the truth is, when dealing with objects in space, even a small shift can accelerate everything. It could happen tomorrow, or it might quietly disintegrate years from now. There's a razor-thin line between speculation and certainty. And yet, there's an eerie possibility that it already happened. The signals we're receiving from Sentinel-9 could be delayed or distorted by ionospheric interference or deep space echoes. In space science, we're always peering into the past. Light and radio waves travel across vast distances, meaning we often witness events long after they occurred. It's not impossible that what we're tracking is the echo of a final transmission, a cosmic ghost flickering out. If the spacecraft does re-enter intact, the result could be dramatic. The friction with Earth's atmosphere would ignite its outer structure, producing a fiery streak across the sky. Think of a long, glowing trail, brighter than a meteor shower, possibly even visible in daylight if it happens at the right angle. It would be more than a re-entry. It would be a spectacle, a rare moment where the sky itself reminds us of the forgotten ambitions we once launched toward the stars. Imagine stepping outside one evening, just as the sky begins to darken. At first, there's nothing unusual until a sudden streak of light tears across the horizon. Brighter than anything you've seen before, it blazes through the atmosphere like a molten arrow fired from the stars. Sentinel-9, after decades of silence, would announce its return not with a whisper, but with fire. The explosion would light up the sky for several seconds, possibly even minutes if fragments hold course. Cities across the globe, New York, Cairo, Tokyo, could look up and witness the same celestial fireworks show. No telescope needed. Just bare eyes and an open sky. Its re-entry would outshine most meteor showers. The brightness could rival that of the full moon, casting strange shadows and bathing streets in a soft, unnatural glow. Pieces of its structure, burning from friction and speed, might break apart mid-descent, each fragment glowing like a falling star. For some, it would be breathtaking. For others, unsettling, like watching a piece of history burn away right above our heads. And yet, there's something profoundly human in that image. A spacecraft launched with hope, lost in time, and finally returning to us in one last fiery arc. It wouldn't just be a spectacle. It would be a moment that connects generations. A reminder that even in silence, the things we send into the cosmos never truly disappear. They wait. And sometimes they come home. The fall of Sentinel-9 may seem like the end of an old machine's journey, but in truth, it's a powerful reminder of something much bigger. In science, even the smallest events can unlock new understanding. By studying its descent, the materials released, and the radiation patterns emitted during re-entry, scientists can learn more about long-term space exposure, orbital decay, and the lifespan of deep space tech. That knowledge helps us protect modern satellites, build stronger space stations, and prepare for future interstellar missions. But let's step even further back, to the scale of the cosmos. In the grand dance of the universe, explosions are not just endings, they are beginnings. When massive stars like Antares or VY Canis Majoris reach the end of their lives, they don't quietly fade. They go out in supernovae, titanic explosions that forge the universe's heaviest elements. Gold, platinum, uranium, all are born in these cosmic furnaces. The iron in our blood, the calcium in our bones, the oxygen we breathe, these came from stars that lived, burned, and died long before Earth existed. Sentinel 9 may not be a star, but it's a part of this cycle, a product of Earth, launched into the void, and now returning, perhaps to break apart and scatter back into the planet that gave it birth. It's a reminder that everything is connected, that even the cold silence of space holds the echoes of life, death, and rebirth. And, just like the stars, what we create and what we lose can shape the universe in ways we're only beginning to understand. Despite how dramatic it all sounds, there's no need for panic. Sentinel 9's return poses no real threat to Earth. Most of the spacecraft will burn up during reentry, reduced to glowing dust high in the atmosphere. The chance of any debris reaching the surface is extremely low, and even if it does, it would likely land harmlessly in the ocean or a remote area. What we'll witness is more spectacle than danger, a fiery performance, not a catastrophe. In fact, events like this can have fascinating side effects. The energy released could briefly excite particles in the upper atmosphere, creating faint auroras or subtle shifts in ionization levels. Harmless, but beautiful. These fleeting atmospheric phenomena are a bonus for scientists and skywatchers alike. What's even more impressive is how prepared we are. Around the world, neutrino detectors, devices that capture ghostly particles released in high-energy events, are constantly listening. If Sentinel 9 systems destabilize further or emit any final surge of radiation, we'll know. These detectors form part of a global early warning system that allows astronomers to mobilize in seconds, tracking events long before the light ever reaches us. It's a quiet, invisible network, keeping watch for moments just like this. We're witnessing the final breath of a giant, a farewell millions of years in the making. Sentinel 9, once a marvel of engineering and ambition, is now preparing for its last great moment. It reminds us that in the grand scheme of the universe, even our boldest creations are temporary. And yet, within that fleeting existence, they leave a mark on our skies, in our science, and in the stories we pass down. Think about it. This spacecraft was launched by hands long gone, operated by minds that dreamed of reaching the stars. Decades later, it returns, not to be forgotten, but to be seen one final time. Its descent is more than a mechanical event. It's a cosmic whisper, telling us that nothing in space is ever truly lost. Everything circles back. Everything leaves a trace. In a universe so vast, so ancient, and so mysterious, it's easy to feel small. But moments like this remind us that we are part of it, that our curiosity, our inventions, and our questions are threads in the fabric of the cosmos. So, keep looking up. There are countless sentinels out there, some waiting to be found, others already falling toward us, wrapped in silence and starlight. The universe still has stories left to tell. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think might be out there, just waiting to return.